We see OBS.
Thank you. Yes, that is what we are using. OBS. Might as well. It's repurpose it, right? I'm not gonna let all that experience
It's
go
good
to waste.
software.
It's good software. It's free. It's free.
Open
So
source.
open source. Anyway, all right. Let's go ahead and get started. Um, Good morning. Happy Tuesday morning, AP Computer Science A. This is April 28th. Hopefully, you're all having a great day so far. Couple things before we get started. Number one, your free response question practice, or not practice, your free response question assessment. The first one was due over the weekend. Everybody did it and did a pretty good job. I want to make sure I go over some common points of feedback that I have for you on that. I did post the answers on Google Classroom, so the answers that I've created. Again, they do not represent the only possible solution. It's just the solution that I happen to come up with. Some of you came up with some pretty creative solutions, some excessively lengthy ones, and some really short ones. But it was cool to actually see how a lot of different people approach the problems. But I want to give you some of my specific points of feedback on that problem. Again, I did post the answers and your grades are in Aspen, but if you do have any more specific questions about, hey, Mr. Giorgio, why did I get points taken off here, or why did I get this specific grade, please, please, please do not hesitate to ask. Okay, you can send me a Hangouts message, you can send me an email, whatever. The other thing I want to point out is that I'll give Andrew credit where credit's due. Andrew actually came in and suggested, he said, hey, Ms. Giorgio, do you think you could post the second progress assessment when there is one at the end of the class on Thursday? Do you think you could post that on Google Classroom instead of sending it via email? For my math classes, I've been doing everything via email because I think it's easier to keep the email thread in one spot and it's easier to attach photos to the email. But I think for the purposes of this class where we're sharing typed documents, it probably is a little faster to go on Google Classroom. So we'll try it out. We'll see how it works. But yeah, I'm going to go ahead and post the second progress assessment. That will be at the end of Thursday's class. It'll be just another free response question like this one. I am going to post that on Google Classroom instead of sending it via email. Okay, I may do both, but it will be posted on Google Classroom, and I'm going to ask that you submit via Google Classroom. Is that okay with everybody? Is that a-okay? Is that clear? We're going to give it a shot. If it works out better, then that's great. And if some people are like, hey, I had more trouble with that than via email, then we'll switch back. But I think it's all about just trying it and see what works out. Okay. But if you do have questions on that or comments or concerns on that, just let me know. All right, I want to just, again, go over our first free response progress assessment question today. After I do that, I want to show you, I have another one that I prepared for you. I did upload it this morning, so hopefully you got a chance to take a look at it. The thing that's specifically special about this problem is that this is one of the ones that the AP that the College Board, specifically on AP Student, they're like, hey, we recommend going over this problem with your students to prepare them for the exam. It's not stated that explicitly, but pretty much that's what they're saying. So I do want to make sure I go over this one. I think it's a pretty, really cool problem. It's another one of those problems where you don't want to get lost in the scenario of what's going on. What you actually have to do is very straightforward. And I feel like that's a common theme. The more I'm looking at these free response questions, the more we're looking at them together. A common theme is a lot of times the scenario can be complicated and can be somewhat involved for these types of questions. But when you actually break down what's being required of me to do, a lot of times the tasks are pretty straightforward. All right, but I'll talk about that more as I go through some things. I also made sure to update this strings and things document, which contains all of your string methods. You may remember this from the very, very, very beginning of the year, or at least close to it. I think this was towards the end of the first quarter. I gave this out to you. I added one method that actually will show up in this free response question. There is a way to do it without this method called contains. It's a string method. The way to do it without it is a little less obvious. And what's funny is that the actual solution that the AP, that the College Board provides does not use the contains method. And I'm like, wow, this would be like way easier if you just said contains. But I'll show you both solutions, the one that uses it and the one that doesn't. But I figured, hey, if there's a problem that actually could be beneficial to use this on the AP exam, then I'm going to add it to the document. So I gave you a little description of the contains method. I'll talk about that a little more as we get closer to it. And then the last thing I want to do today is I want to specifically go over, this is the free response question that it's specifically we're going to look at today. This is the scoring guide for that question, and I want to talk about how these free response questions are actually scored, because sometimes if you don't know the actual full coding solution to a problem, if you're looking at a problem, and especially when you're like on the fly taking the exam and you're like, man, I'm missing it, and I just don't think staring at it is going to get it. You can try to get as much partial credit as possible, and I'll talk about how you can actually do that today. All right, so that's our lineup of agenda items for the day. So let's go ahead and get started. Oh, and by the way, your proposals that you submitted to me, I will get back to you today. I have to look at those this afternoon. I looked at some of them already. It's been kind of crazy, to be very honest, the past couple of days. But I will look over those, and I will get back to you with some feedback. There are some of you that I think need a little bit of refinement with your idea, and there's others that I'm like, wow, that sounds really good, and I think you can just roll with it. So make sure, if you haven't submitted that to me, I don't know why you haven't, but please make sure you do. Okay, I'll get back to you this afternoon. All right, in any case, let's talk about our progress assessment free response questions. So what it involved is it involved this thing of the scenario of a digital sound sample. And a digital sound sample can be represented as an array of integer values that corresponds to the volume of sound at the time interval. So it's like picture like any sort of sound editing thing. A lot of times you move that crossbar across the sound from left to right, and the actual volume of the sound, the amplitude of the sound, it's a good old pre-calc term as well, can be represented by this array of integers. All right. So what we had to do in part A is we had to limit the amplitude to be between a certain value. Okay. So if, for example, it told us to limit the amplitude to 2000 and these were our samples, then anything greater than 2000 has to be set to equal 2000, and anything less than negative 2000 has to be set to equal negative 2000. So that was pretty much the parameter here. Okay. A lot of times I just use that instruction to guide the code that I write. And sometimes it may be beneficial for you to just think about this before even writing code. Like, just think of a process that I'm going to do. It says this method of limit amplitude, we want to change the values in the sound to have an amplitude greater than limit. Values greater than limit are changed to limit. Values less than the opposite of limit or negative limit are changed to negative limit. The limit is the amplitude limit, and the precondition is that it's greater than or equal to 0. So we don't have to worry about if the amplitude is negative. We don't have to take the absolute value of it. Some of you did that, and that's absolutely fine, where you said you took the absolute value of the limit. That came from probably this statement right here, where we said the limit is its absolute value. That's fine. That's not going to change anything, but you don't have to do that. So what I did here is I just used this description to guide my code. I said, well, we're going to keep track of the number of changes because that's what we want to return. I want to go through the whole list. That's done with a for loop. You've seen that syntax a million times. And I want to say exactly this. Values greater than limit are changed to limit. So if we're bigger than the limit, let's set it to be the limit. And then that tracks the number of changes. Well, values less than the opposite of limit are changed to the opposite of limit. So if you're less than negative 1 times the limit, you change to negative 1 times the limit, and then increase the number of changes. And then at the very end of all that, we're just going to return the number of changes. So a lot of times, these instructions can just guide you throughout the problem as to what to do. Values greater than limit are changed to limit. Oh, well, let's see. If you're greater, then change. If you're less than negative limit, then change. And otherwise, do nothing. Does that make sense to everybody? How that's done? So I think having that process and going through that process can help when you have to then translate that to code. Be like, all right, well, how do I do that? How do I check to see if something is greater than the limit? Well, that's just an if statement. If samples at that specific index is greater than limit. How do I check if it's less than negative limit? Another if statement. How do I actually run through the whole list? That's a for loop. All right, so a lot of times thinking in terms of that can help you go forward. All right, the second thing we had to do was deal with trimming the silence from the beginning. There are a lot of ways to do this. I'll show you the way that I came up with. I also tried to comment it for you just to give you a couple comments as to what I did. Some of you came up with, again, more creative ways to do it, and that's fine as long as it still did what it needs to do. That's a lot of times what the AP exam is concerned with. But what you have to do is especially when you have a recorded sound, you usually press record, there's a little bit of silence, and then you pick up. This should just trim all that silence from the beginning. Essentially, we want to check our array until our array runs out of zeros. We want to, or until we encounter a non-zero element in the array, this string of zeros is expired. We want to get rid of all that stuff from my array. So if I'm starting with an array like this, I want to end with an array like this with that beginning silence trimmed. Something to keep in mind is that doesn't mean that we want to get rid of all of the zeros in my list. You may notice here, I don't want to get rid of all of the zeros. These zeros are still here. These zeros are still here. These zeros at the end are still here. So we can't just do like, if you find a zero, then remove it. We also can't just do remove, because a lot of people did dot remove. Because this is an array. It's not an array list where we can just go ahead and say, oh, that dot remove. When we're just dealing with an array structure, it's important that we have to essentially copy these elements into a new array. And that's exactly what I did in my solution here. I started with the fact that the number of zeros is 0. And what I said is while samples at index number of zeros is equal to 0, I'm going to add number of zeros plus plus. So essentially what that's going to do is that's going to check while samples at index 0 is 0. If that's true, then we're going to increase this to say there's 1 0. Then we're going to check index 1. See, is that 0? If so, then now we have 2 zeros. And we're going to check index 2. If that's 0, then we now have 3 zeros, right? So I found, actually, as I was doing this, I thought it was a little clever to be able to use the same variable in like a bunch of different spots. I found that I was actually keeping track of, the number of zeros that we have, and then using a separate variable to increment the array index. But then I thought to myself, wait a minute, these two variables are just doing the same thing. Like they're equal to the same values at the same time. So you can actually condense it down to just one. So once I figured out how many leading zeros there were, what I did is I created a temporary array to copy the values. I made its size equal to the length of the original minus the number of starting zeros. So like if there were 4 starting zeros at the beginning, then I need 4 fewer positions in my new array. And then I started with my new sample position as 0. You're going to see where that comes in a minute. This loop now just copies the values into the new array. Starting at number of zeros. So in our example up here, we would start at index 4. We would start here because I don't want all that stuff. I want to copy everything from here down, right? So I'd start there. We go to the end and increase by 1 every time. I say new samples at new sample position. So we're going to start by storing index 0 in our new samples array to equal samples at index I. So here it's going to say, I want this index 0 to equal this index 4. Then when everything increments, it's going to say, I want this index 1 to equal this index 5. And that's how it's going to carry throughout the whole loop. And then at the very end, what we want to do is we want to have samples. Where is it? Right here. It says it somewhere. We want samples to refer to now the new array. We don't want it to refer to our original array. We don't need to return it. We just want it to now. It says it right here. The instance variable samples will refer to that array. So in order to do that, we just say samples now refers to our array of new samples. So that's the pointer of samples to refer to the newly created list. All right. Again, that is far from the only solution that you could do, but that was just one that I came up with when I was working on it. All right. But again, I kind of went step by step based on what was provided. I said, well, in order to trim all the silence from the beginning, this was sort of my thought process. I said, well, first, I need to figure out how many leading zeros there are. Like I need to figure out how far to trim. So that was the purpose of this code. After that, I said, okay, now that I've identified where I'm going to cut off, I need to then take all the rest of the stuff and copy it over to a new list. So that was the purpose of this code. I created the list and then copied it. And then after that, I needed to now set samples to refer to the new array, and so I did that. All right? So a lot of times, thinking about it in terms of those discrete tasks hopefully can help you out, where you can say, well, let's think about what I have to do. In order to trim the silence, I need to determine how much am I trimming. Then I need to copy the stuff that I'm not trimming, and then I need to just change the reference. So that's 3 steps. Does anybody have a question about that? Take your silence as no questions. Great. All right. Let's go to the next free response question that I had prepared for you today. Again, this is one that the College Board recommends that I go through with you. So I'm like, all right, well, I guess we're going to do it then. This says, and again, you have access to this on Classroom. So if you want to follow along on Classroom, you certainly can. I posted it there this morning. It says, a student plans to analyze product reviews found on the website by looking for keywords in posted reviews. The product review class is used to represent a single review. So when you leave a review on a website like Amazon, you have this product review class. It says it consists of a name and a review of the product. So you have name, review. This is a very basic object, very similar to ones that we've actually written in class when we first started talking about objects. All it does is it has two arguments, the name of the product and the actual text for the review, probably a big long paragraph. Stores those in these two variables, and then we just have a couple getters. Get name returns the name, get review returns the actual text of the review. All right, so that's all that product review thing does. Now we have those, we have this class called Review Collector. What Review Collector does is essentially collects all of the reviews. Think of the fact that when you go on a website like Amazon or any sort of site with reviews or comments or anything like that, any sort of manufacturer, retailer like Newegg, to use a computer one, Walmart, any of those, you would see this list of product reviews, and that's exactly what this Review Collector class is attempting to do. We have two array lists here. One array list of product reviews, so it's an array list of this stuff, and one array list of strings. Okay, we have a constructor here. All the constructor does is it goes ahead and just initializes the array list and initializes both array lists, the one of product review and the one of strings. It adds, we have this method called add a review to the collection of reviews. So that's what we're going to do in part A. And in part B, we're going to return the number of good reviews for a given product. It'll talk about that in a bit. So part A says we want to write the add review method. The add review method adds a single product review represented by a product review object to the review collector object. The add review method does the following when it adds the product review. And this, in my opinion, I'm like, these are the key words. This is what we're doing. All right. First, product review object is added to the review list instance variable. Well, I can do that real fast. I can say, watch, with one line, what's the thing called? Review list. Not with my caps lock on. I just got so excited. Review list dot add prod review. Done. Product review is added to the list because we said it right here. We receive this product review called prod review, and I'm going to add that to the list. Okay, that's quick, simple. We've accomplished that. Next, it says the product name from product review object is added to product list, so we can get the product name. If the name is not already in product list, so that's important. So we need to say, if this name of the product that came in the review is not in the list, then we can add it to the product reviews. All right, so I'm going to start with this variable called Boolean. We'll call it found. Okay, we'll start it out as false. So suppose it's not in the, we're going to suppose it's a new product. What I'm going to do is I'm going to go through the list. So we can do for in I is 0. I is less than review list. Or sorry, product list, I believe, right? Because what's the name, the list that we have here? Product list is the list that we actually have of all the products. Size, because it's an array list. I++, so go through the list. Let's see, do we find anything with that same thing? What I'd want to say is if product list at index I, dot get, because it's an array list, dot get I. Product list is, again, a list of strings. So we're just saying, hey, do these strings match the string that's provided in the product review? Well, how do I get the string that's provided in the product review? So we want to say if that dot equals the string provided in the product review. How do I get that string? Well, if I look to the product review object, which is up here, I can use this object called getName, or this method called getName. So I can say if that dot equals prod review dot getName. So what that statement is saying is if we are going through the list and we find that the product is already, the name of the product is already in a position in product list, then I can set found to true. Okay? The benefit of that is that goes through the whole list for us and checks all of that right away. And so now we can say if found is still false, meaning that it never actually found anything in the list, then we can add it to the list. So then we can do product list dot add, and we can add prod review dot get name. Okay, and that's it. Does that make sense how it was done? Try not to get bogged down in the syntax. The syntax is a little complicated with an array list, but understand the general process. What I did is product review object added to the review list. Done. That's a quick one-line thing. We added it. All right. Then I want to add the product name to the product list if it's not already there. So what I'm doing is I'm going through the list to see, is it already there? Do we actually find the name of the product review in the list? And if so, then we're not going to add it. But if we don't, if we go through the whole loop and we find that that's still false, then we're going to throw it in there. Okay. Does that make sense how we did that? Okay. If you have a question, let me know, though. Again, you can follow along on Google Classroom if you need to. Part B says we want to write the get number of good reviews method. I think this is a pretty silly description, but we have to go with what they provide us. It returns the number of good reviews for a given product name. It says here, a review is considered good if it contains the string best in all lowercase letters. If there are no reviews with a matching product name, the method returns 0. Note that a review that contains best in all caps, best, or best with a capital B is not considered a good review since they're not all lowercase, but a review that contains asbestos is considered a good review since they're all lowercase. I think that's really silly, but essentially what it means is we're searching through that whole review text and trying to find the text best in all lowercase. All right? I was thinking to myself, well, if we're searching through this big string to try to find this, there has to be a method that does that. Like, there has to be a method to see, hey, is this string a substring of another? And actually there is. That's what I added to the list. There's this string method called contains, where you can check, hey, does this string contain this thing? You can see here in my little example, if string S is Animal Crossing New Horizons, great game. We could say S dot contains sing. That is true because you can see it right here. S dot contains Nook. Definitely not true. It's not anywhere in here. S dot contains cross. It does contain cross, but not in all caps, so that would also return false. So this method is something that you can use on the AP Computer Science A exam. I would highly recommend. As you're taking the exam, you are allowed to have your notes. So I'd recommend having this string guide on hand. Probably pretty useful. All right. Again, there is a way to do it without contains, though. So what I want to do is we want to get the number of good reviews. So let's start with saying, make a little counter to count the number of good reviews. So int num good reviews. Start it with 0. Okay. What I want to do is we're given the product name. So I can go through, what I can do is I can go through all of the product reviews to see, hey, do we actually find the same product name? So I'm going to say, go through the product reviews, the list of product reviews called review list. I'm going to say, hey, if any of those .getName is the same as the name I've been provided, then I want to search that review to find the word best. Okay, that's sort of the general thought process. I want to say, let's search through the list until I find the same product. Once I find the same product, we're going to go ahead and search the review. And if that review contains the word best, we're going to say, hey, we got a good review. All right? Watch how that's done. I'm going to start by going through the list. So I'm going to say for int I is 0, I is less than. We want to go through the review list. And also, by the way, the AP exam will give you this list a lot of times where it's nice. So you can see like, hey, here's all my tools that I have to work with. So we want to go through review list. I want to then say if, so let's say if we find that product, because see they're giving us, I just pointed on the screen like you could see that. They're giving us a product. So I want to say if review list dot get at index I want to say if that product name, notice I can use dot, I think it's get name, right? Is it up here at the top? Right here, dot get name. If that name is the same as, so put in parentheses, dot equals the product name that was provided. Do you see how that works? If it's the same as the product name that was provided, if the name of the review at that position is the same as the product name provided, then I want to scan the review and try to find the word best. So the review, I could say string review text equals new string review list dot get at index dot get review. Okay, it's not necessary that you do that, but what I can do, review text, I can just store the actual review in the string called review text. That'll make it a little easier to refer to instead of saying review list dot get review every time you want to look through that. You could certainly leave it that way, but I think it's a little easier to just say, hey, let's create this little string. And what I want to do is I can say if review text dot contains the string best, then we found a good review. So I can say num good reviews plus plus. And that's pretty much it. And then at the very end, we just want to make sure we send it back. So I say return number of good reviews. Okay. Does everybody see how that works out? We're starting by saying, well, assume there are no good reviews. We're going to go through the list. We're going to say, hey, if the product name is found in our review, in our lists of reviews, remember these reviews have product names and review text. So if we actually find the product name, then let's store the text here. I'm going to say if the review text contains best, then increase the number of good reviews by 1. And then after we go through that whole process, return the number of good reviews. All right. The way that this was actually done without using the dot contains method was super clever. I don't know if I actually would have thought of it, but I mean, maybe just given enough time. But what they did is they said if review text dot index of best, remember index of returns the position of that within the string. They said if that's greater than or equal to 0, which I thought was super clever. And that will definitely work as well, because if you find best, then it's going to tell you the position at which it was found. And the way that index of works is if it doesn't find something, it returns the value of -1. Very clever. I don't know if I would have thought of that, but especially not on demand. I'm sure I would have thought of it if I thought about it for like 30 minutes. But on demand, that would have been a little tricky, but really, really clever to do that. And then I was like, wait a minute, there has to be a dot contains method, and there definitely is. So you could just use that instead if you prefer. Okay, either way. Questions about that at all? All right. We don't really have time today. We're kind of out of time to talk about how the exam is scored specifically. I'll save that conversation for next time on Thursday. One thing I do want to tell you today is I do want to give you just a couple general comments, like I said, based on your free response question responses here. So I wrote down just a couple notes here I want to share with you. One thing I think that was important, I tried to emphasize it as much as possible today, is to just follow the instructions. Don't get overwhelmed in the scenario. Don't think that this code is just magic. Follow the instructions as to what you have to do. So it's almost like a checklist. Think of, I have to accomplish this. All right, we accomplished that. I have to accomplish this. All right, we can accomplish that. And then I have to make sure I return what I need to return and do what I need to do. All right, so almost treating it like a checklist of things, saying, okay, I need to do this, then I need to do this, then I need to do this. That might help you stay organized. One note that I wrote down is to not confuse your array syntax with your array list syntax and operations. In an array, you can't just remove something. You can't just do dot remove. That's the convenience of an array list, but unfortunately, in an array, that doesn't work out. So some of you in this example just tried to do, where are we here? In the trim silence from beginning, you said, oh, if you find 0, then just remove it. I mean, that's all well and good, but you can't do that in an array. That's why it is probably an array, because with an array list it would be too easy. Um, another note that I have is make sure you return what you need to return. Some of you actually forgot to just return the number of changes here. You did all of the converting properly, but you didn't actually track the number of changes or return it. Make sure that you actually follow like what the method has to return. It often tells you here in the return type as well to say, oh, it needs to return an int, so make sure it does. Here, it doesn't return anything, so there shouldn't be a return statement. All right. And last but not least, the benefit of you guys being able to work on this at home is you also have your computers to work on. So in doing these problems, I highly recommend, whether it's a graded one or ungraded or extra practice you do on your own or whatever, test your code. Put it into an IDE like Dr. Java or Eclipse and see if it works. Or if you don't have access to that, actually run through with some examples. So once you type this, right, and you're like, I wonder if that actually works, make a sample array. Just create one and then trace through the code on paper and see, hey, does this actually work out? Does this code actually do what I want it to do? Again, you have the advantage of using an IDE at home. You could use Dr. Java if you wanted to just paste it in there and see, hey, does this code actually work out? You'll probably have to do a little more with the, actually making an array in there and actually making sure your public static void main string args is all there. But you could just put it in there and say, hey, does this work? Again, you could also trace it out on paper. So that's what I highly recommend. Don't just give up and don't just be like, I don't know how to do it, or I'm stuck, or I'm confused. Think about it. Figure it out. I have a lot of confidence that you can do that. Okay? So those are the notes that I just wanted to present to you. I think testing your code is particularly helpful. It'll really help with tracing code and give you some good practice on how to do that. All right? Like for any of these problems, before you submit them to me, especially if they're graded, you should create a little sample, some sample data, and just run through your code to see if it does what it's supposed to do. Whew. All right, that was a lot of talking today. Does anybody have any questions or comments on anything that I've discussed? We went through the progress assessment, just went over that in detail, and I did an additional problem with you that the College Board recommended that I do with you. So that's good. That's probably one to pay particular attention to. Wink, wink, nudge, nudge. All right, very good. I also updated this strings and things notes document for you, so that's a really handy resource for you to have. I highly recommend having that on hand while you take the exam. It is open notes, so I recommend having that by your side. If there's not a string on the exam, then I don't know what's gone wrong with the world. So please make sure that's there. All right, that's all I got for you today. I'll wrap it up here. Thank you so much for your attention and focus today. I hope that you have a great rest of your Tuesday. Again, I will see you on Thursday. It's assumed that within this time you're working on your final project. I'll get that feedback to you on your proposals today, so you can look forward to that as well. All right. Thank you again, and have a fantastic rest of your day.
Bye, Mr. Giorgio.
See you later.
Mr. Giorgio.
Bye.
See you, Giorgio.
See ya.